everyone. This video is about the data models. What are the data models that we must learn about before designing the database? So these are the data models that I have mentioned here in this slide. So hierarchical network models, relational model, entity relationship model, object-oriented model, object relational and XML, and other two types are big data and NoSQL. These are the modern data models that are being used nowadays. So let's start with hierarchical model. So here I have given one example from the animal, pet and wild animal. These are the two types of animals being categorized. And under pet you have dog and cat, and wild animal you have lion and leopard. So how does it satisfy the properties or characteristics of hierarchical model? So hierarchical database model arranges the data in a structure similar to a tree, as you see in this picture. So first, there is a main root, which is the start of the tree, that is your animal. Other data arranged under the main root. So first categorization, pet and wild animal. Furthermore, other nodes connect to the main node as children nodes. Another set of nodes are connected to these children nodes. So this model helps to represent one-to-many relationship among two data types. So each child node will have a single parent. So dog cat has a single parent, pet has a single parent, wild animal has a single parent, and lion leopard has a single parent. Wild animal. This is a type of your hierarchical model. It's a network model. So it should be in the format of a network. There should be many connection in between the entities. A network model is an extension of hierarchical model which arranges the data in a structure similar to a graph that you see here. Store connected to customer, manager, salesman connected to order items, manager connected to only order, customer connected to only order. So unlike in the hierarchical model, a node in the network model can have multiple parents. So order has three parents: customer, manager, salesman. Furthermore, the data in the database created using the network model will have more relationships. This type of linking among the data helps to access data easily and much faster. This model helps to represent many-to-many relationships. Next, relational model. So it is the most widely used popular model and most extensively used model also. Most of the database design actually follow this relational model. In this model, the data can be stored in tables and this storing is called the relations. The relations can be normalized and normalized relation values are called atomic values. Each row in the relation contains unique value and it is called as tuple. Each column contains value from the same domain and it is called as an attribute. Let's see a picture of it. So here say this is an example of a relational model diagram. So a relational database is a single data repository that provides both structural and data independence while maintaining conceptual simplicity. So what is that data independence? We saw that in the last videos. And about conceptual simplicity, we will see one conceptual model also. The relational database model is perceived by the user to be a collection of tables in which the data are stored. Each table resembles a matrix composed of rows and columns. Tables are related to each other by sharing a common value in one of their columns. So as you see in this picture, there are three entities: employee, hourly, salaried. Employee has these many characteristics as employee ID, name, date hired. Hourly has one wage and salaried has two characteristics as stock option salary. And here hourly and salaried is being derived from the employee entity. And you can say that employee is one parent for hourly and salaried. So this circle here, it represents type of relationship. and we will see into detail in the later on in other chapters about this in detail. So see here, this is a relational table design. So here see there are two tables, agent and customer. Above tables here are related to each other by common name, agent code. See the line here. There is a single column common to both of the table. And this relation is represented by the next figure by a relational diagram. Here see, this is the relational diagram. Agent table, customer table. One agent is connected to, one instance of the agent code in agent table can have many relations or many instances in the customer table. And here see there is a key here and there is a key here. Here agent code is the key attribute of the agent table. Customer code, cus underscore code is the primary key of the customer table. So in each table there must be a primary key. What is that primary key again? We will see that later in detail. So every primary key means what? It can uniquely identify each record in that given table. Just remember it. Okay. Mm, Next, come to entity relationship model. So, an entity relationship model, also known as ERM in shortcut, it helps identify the database's main entities and the relationships. Because the ERM components are graphically represented, their role is more easily understood. Using the ER diagram, it's easy to map the ERM to the relational database models tables and attributes. This mapping process uses series of well-defined steps to generate all the required database structures. So here see, it looks kind of your last relational model. Here the main component should be the entities. Student course are entities, and in the oval structures whatever you have connected to the entity, those are your attributes. And this is the relationship mentioned here, enrolled in between the both the entities. So this is a structure of ER model notation. See, there are multiple notations again to the ER model inside the ER model. Chain notation, crowfoot notation, and UML diagram notation. You can follow any type of notation for the ER modeling. Okay, that depends on you. So I'm just going to give you one example here. Other two examples, try to explore it yourself. You will also find this picture in the book as well. So two entities, painter, painting. Painter paints multiple painting. That is why there is a one cardinality here in the left hand side and M cardinality here in the right hand side. This is your chain notation. Same thing can be represented using this crowfoot notation. Where there is a one relation, there should be one line. If there is a multiple M relation, then there should be like a crowfoot. It has three branches towards the printing. Now UML class, so painter, one relation side, one dot 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 one, it paints. Painted by that there are multiple paintings to the painting entity. So it should be 1:asterisk. This is your asterisk. It is for meaning. Next one, object-oriented model. So here, what is an object? Object is an instance of a specific class. It is useful to point out that the object is a runtime concept while the class is a more static description. Objects that share similar characteristics are grouped inside a class. A class is a collection of similar objects with shared structure, that is your attributes, and behaviors, that is your methods. Therefore, a class resembles an entity set. However, a class also includes a set of procedures known as methods. Well, see, this is one picture here. Okay. So This is one object-oriented data model representation. So first you have the object representation where you need to include the entities, their cardinalities or relationship, and what are the characteristics. Okay. In the UML class diagram, that thing is need to be more elaborated. Entity, your line is another entity, and another, it's sort of relationship which includes all the characteristics, that is your invoice. So inside invoice, you have your customer and line, and these are the relationships. 1 is to 1, 0 is to many, 1 is to 1, 1 is to many. And you need to also specify what are those relations. Same thing represented in the ER model. And this is your Crowfoot notation that I just told you in the last slides. Next, I'm moving over to the big data and NoSQL. So, over the last few years, a new web of data has emerged into limelight. Such data have, as always, existed but did not receive the attention that is receiving today. These data are characterized for being high volume, maybe in the size of petabyte size and beyond, so big, high frequency, and mostly semi-structured. These are not at all structured. These data come from multiple and varied resources such as website logs, website posts, random website posts, and social sites, machine generated information such as GPS, sensors, etc. Such data have been accumulated over the years, and companies are now awakening to the fact that it contains a lot of hidden information that could help the day-to-day business, such as browsing patterns, purchasing preferences, behavior patterns, etc. The need to manage and leverage this data are triggered as a phenomenon labeled by big data. You must have heard about it. So the big data refers to a movement to find new and better ways to manage large amounts of web generated data and derive business insight from it, while at the same time providing high performance scalability at a reasonable cost. Uh, can you think of some of the companies that may be using it? Okay, as I told you, for website posts or social sites, you can say Google, Facebook, maybe your Amazon also. And just think about some other companies which may be using this, which need this such big amount of data to handle. I'm going to show you some of the evolution of the data model. So this is the data model. So in 1983, first the internet is born. Okay, now see, this is the latest starting 2009. It's the big the big data. It includes the technology NoSQL, like you use the SQL for relational database design. We are going to mostly emphasize on the relational model, entity relationship model. So these are the years provided and their individual characteristics provided as well. Okay. So this is if I, this here I'm going to stop, and I'll be doing another one video for the last whatever slides that is left here.